Okay, pre-calc, let's go ahead and talk about our last chapter, which is chapter 7, which are going to be all of our conic sections. So we're going to go ahead, we're going to be diving into this conic section today. But FYI, right, there's different types of them. So when you slice through kind of the middle of these, right, these cones, if you think about like, hey, what a cone is and kind of what the stacks are, you, of course, right, if you kind of slice through the middle here, you're going to get a circle. If you kind of slash through at an angle, you're going to get an ellipse. And I also just kind of drew over here the general shape of those. Now today we're going to be talking about our favorite here, which is a parabola. Right, kind of slice through going up and you go through that circle, the end of the cone there. And then if you actually go ahead and slice straight down, you're going to get what's called a hyperbola, which looks kind of like two parabolas back to back, but not so much. Anyways, we're going to go ahead and look at our parabolas here. So let's label the parts that we do know, right? Because we've been dealing with parabolas for a very long time. We know that we have a vertex, right? This vertex down here at the bottom of it. We also know that we have an axis of symmetry. Okay, so we have our vertex and we have our axis of symmetry. The two new things that we're going to be talking about is a focus and our directrix. So this point right here is our focus, and this line down here is this directrix. We, of course, know that our vertex is here on the parabola, and it goes right through the axis of symmetry. All right, and so let's go ahead and kind of define what these things mean now. Now, the actual definition of a parabola is the set of all points equidistant from a fixed point, and we're going to call that fixed point the focus, right? That's our new term that we have today. And a line called the directrix. Again, new term today. So actually, when we're thinking about this, right, is that we're saying, hey, no matter where you're at on this parabola, the distance between your focus and that point and the directrix is going to be the same, right? It doesn't matter if you're going from here to here and here to here, or if you're going from here to here to here to here. It's going to be the same no matter what. So then we also, of course, have our axis of symmetry, which is the line the parabola is symmetric about. And also, it's going to be perpendicular to directrix. And then lastly, of course, is our vertex, which is the intersection of your axis of symmetry and parabola. All right, so let's go ahead and talk about our vertex form, because our vertex form is our friend, right? Our vertex form is that form that we've used always with graphing parabolas. And it is y is equal to x minus h squared plus k, where that all-important vertex point is at the point hk. And our axis of symmetry is at the equation x is equal to h, right? Okay, so now we're kind of breaking it down a little bit more, right? And we're saying, hey, this value between your vertex and your focus, and then your vertex and your directrix, hopefully you can see where I'm kind of highlighting here, those values are going to be the same, okay? That's actually what's called our p-value. Now let's talk about why it's our p-value. So if you want to, you can go ahead and you can actually erase or pause this video and copy this down. Sorry, I'm going to erase these for a second just to show you what we're talking about here. So we're saying, hey, this value between any point on your parabola. So from here to here, right? So from here to this point, this focus point down here, would be equal to this value right here, because it's the distance formula. And then also going from that point down to your directrix is equal to this value over here, right? That's what that's saying. So we're just proving that those are congruent to each other, or that we know that those are congruent to each other. And then we're going to go ahead and kind of change those to the equation that we want. So you don't have to copy all of this down, but you do need to know that x minus h squared is equal to 4p times y minus k, right? So, and also the idea that you also need to know is that the distance between our vertex and our, purple one, right? So the distance between our vertex and our focus, and the distance between our vertex and our directrix is going to be known as that p-value. All right, so that's our p-value that we have right there. Now we can kind of look at this equation, and if you hopefully you did copy down that x minus h squared is equal to 4p times y minus k. And if you kind of want to change it over, just kind of let's manipulate this a little bit, is that I'm actually going to solve for y. So we're going to go ahead and divide by 4p. So we're going to have 1 over 4p times x minus h squared is equal to y plus k. And then we're going to minus k. So 1 over 4p is 1 over 4p times x minus h squared plus k is equal to y. Okay, now this looks like our vertex form. And the thing that we can go ahead and kind of take away from this is that that stretch value that we have, that 1 over 4p, that a value is equal to that 1 over 4p value, right? So a is equal to 1 over 4p. And then we can actually go ahead and you can rearrange this a little bit and say that our p value is equal to 1 over 4a. Either one of those works out, right? And we'll kind of come back to that in a little bit. But FYI, that's really helpful going forward. So looking at our standard forms here, because we're going to go ahead and talk about two different types of parabolas. We're going to start with our x minus h squared, and this is just plus or minus means if it's opening up or down, right? So these parabolas are the ones that we're used to. They open up, or they go ahead and they open down. Now we're also going to go ahead and we're going to talk about what happens when you square y, because when you square y, it's no longer, we're not really worried about it being a function. We're just kind of talking about the shape of it. So now these parabolas are kind of opening on the side, and they can be going left and right. Just as a heads up there, those are the two differences. All right, so our vertex, no matter what, our vertex is still going to be at the point hk, right? That's always going to be your value for your vertex, no matter if you're opening up, down, left, or right. However, your axis of symmetry, if you're opening up or down, if you're squaring your axis of symmetry is x is equal to h. But if you're going side to side, our axis of symmetry is y is equal to k. So if your p-value, right, if your p-value is positive, you're going to be opening up. But if your p-value is negative, you're going to be opening down when you're squaring your x. And then, of course, if your p-value is positive, you're going to be opening right if you're squaring your y. And if it's negative, you're going to be opening left, just as a heads up there, right? So going left and right, those are pretty straightforward with the direction of your parabola. So remember that p-value is the distance between your vertex and your focus. So when we're thinking about the point for our focus, we know it's going to be at h and then k plus p, but your directrix is now going to be at x is equal to h minus p. And then if you kind of have the ones that you are going left and right, we're now going to have h plus p, k, and our directrix is at the line x is equal to h minus p, because our directrix is now going to be a vertical line. All right, so let's put this actually into some practice here, looking at our examples. So example number 1, we're going to write the equation of a parabola with a focus at 3, -4, and a vertex at 1, -4. Okay, so first things first, kind of figuring out the direction and where we're going with this one. We know that our y values are going to be the same. So we know that this parabola is opening left or right. Okay, I also know that no matter what, this is the point hk. So if we're thinking about our equation that we're going to use, we're going to be using our y minus k squared is equal to 4p times x minus h. All right, well, we already have our k and h values. That's ready to go. We just have to find our p value. Okay, so again, our p-value is the distance, right? The distance between our focus and our vertex. So one way that we could do is that we could actually graph these, right? So we know that our vertex is at 1, -4. So here's our vertex down here. actually going to go ahead and put our vertex right there, and our focus is at 3, -4, so here's our focus. So we could just count this amount right here. So we're like, hey, our p-value is 2, but the other way, of course, that we know that is that we're going to say our p-value is equal to 3 minus 1, which is equal to 2. Okay, so the other thing here is, of course, our p-value is positive. So our p-value is positive, meaning that we're opening left, but we can also see that from our graph because our focus is going to be inside our parabola. So our parabola is going to be going like this. All right, let's go ahead and write our equation. So we're going to have y minus our k value, and our k value is 4. So y plus 4 squared is equal to 4 times our p-value, which is 2, times x minus h. And our h value, sorry, I should put that in. Our h value is 1. Okay, so we now have y plus 4 squared is equal to 8 times x minus 1. Okay? All right, so we now need to go ahead and kind of figure out, we have our vertex, we don't have our stretch. So we don't know how wide this parabola is opening up. We don't know, it could be like this, it could be very wide. We don't quite know how much is opening up. So one way, of course, is that we could use that equation that I talked about. I'm actually scrolling up. And we know that A is equal to 1 over 4p, so we can think about it this way. So A is equal to 1 over 4 times p value, which is 2. So we know that our A value is equal to 1/8. All right, so our A value is equal to 1/8. The other way that you can think about it is that, hey, if you actually were going to go ahead and put your A value over here, you would have to divide both sides by 8. So it's the inverse, it's the reciprocal of this value right here, right? So it's going to be 1 over 8. All right, let's think about our vertex values and our parabola. We've been graphing these forever. Over 1 up 1/8, that's not going to be very fun. I'm actually going to go ahead and kind of zoom in here, right? So I'm going to go over to or up to 4 divided by 8 is 1/2. So I can kind of throw those values in here, right? Okay, then I'm going to go over 3, 9. 9 can't be divided by 8. Oops, 16. 16 can be divided by 8. It's 2. So I'm going to 4 that way. 4 and 2. And then the next one I can divide by 8 is 64. So I'm going to go up, right? We're going to go up 1, 2, 3, 4, 5, 6, 7, 8. And over 1, 2, 3, 4, 5, 6. Oops, I lost it. 1, 2, 3, 4, 5, 6, 7, 8. So our next point is going to be here. And I can't do that on the other side, but I have enough to graph our parabola through these values. There we go. And of course, add arrows onto the end. Now the other thing I would kind of get in habit of is just to remind ourselves that our directrix also exists. It's a nice line to kind of throw on with a highlighter. And just to double check that distance between focus and vertex and directrix is the same. Right? That's the whole key of it. That's what we're working with. Okay, so now with example 2, we are now given the equation and we're identifying the vertex, axis of symmetry, focus, and directrix. So let's go ahead and start writing out these values. So we're looking for our vertex, our axis of symmetry, our focus, and our directrix. All right, well, vertex is easy to pull out. It's simply just the point 2, -5. That's an easy one. We also know that we're squaring our y value, and we have so meaning that our axis of symmetry is going to go ahead and be our y is equal to -5. So we have that y is equal to -5. Okay, so this parabola is opening side to side, and it's actually going to go ahead because this value right here is going to be negative. We know that it's going to be opening to the left. So we're going to go ahead and we're going to be opening to the left this way. Let's plot some of the values that we have. We have our vertex at 2, -5. So we're going ahead down here and plotting our vertex just to kind of get some values. So we now need to find our focus and directrix. Okay, so we know that this -12, right, is that -12 is equal to 4p, meaning that when we divide by 4, we get -3 is equal to p. So For our focus, we're going to be moving -3 direction, and for our directrix, we use a +3 direction, right? All right, so our focus is now going to be at the point, we're going to go ahead and take 2 minus 3, so we now have 1, -5, sorry, -1, there we go, sorry, -1, -5, and then our directrix is going to be at 2 minus -3, so 5, sorry, x is equal to 5 on this one. All right, so kind of putting these points in, they're always good to kind of graph here and get an idea as to where your parabola is going. And here is our directrix. Okay, last thing, of course, that we need is that we need to graph it with our stretch. And we know that our stretch is -1/12. So I have 36 can be divided by 12. So the first point I'm going to do is up 6 and over 3. So first point I'm going to graph is this one, and then down 6 over 3. And then I'm also going to go ahead and do up 12 and so starting from here, up 12 and over 12. So 1, 2, all the way up here. And that gives us enough to graph this parabola, kind of coming through in this direction. Let's see if I can kind of fix these up a little bit. Oops. Get that parabola through some of these points. I know it's probably a little bit easier with a pencil on this one, but going through some of those. All right, so just kind of parabolas that we've graphed in general, just finding where our vertex is. Of course, the new thing is finding that p-value and our focus. So let's actually go ahead. Our last example together is that we are going to write the equation of a parabola with a given focus of -7.5 and a directrix of y is equal to 11. Okay, so if my focus, and if you kind of want to like, I don't know, sketch these out for a second, is at -7.5, so we know that our focus is somewhere going to be like here, and we know our directrix is going to be up here, is that we know that this parabola is going to be opening downwards, all right? So just as an idea as to what we're thinking about here. So first thing that we know is that our vertex, right? Our vertex is going to be on the same x value. It's going to be at 7 comma something, and it's going to be right in between. So we know that our directrix and our focus. So I'm just going to take my y value. So I'm going to have 11 plus 5, and then I'm going to go ahead and divide it by 2. So my y value of my vertex is going to be 8. So our vertex is now at 7, 8. I just need to go ahead and find my p-value, right? That p-value, and it's going to be the distance between 8 and either my directrix or my focus here. So I'm going to go ahead and say 5 minus 8, which is equal to our -3. Great, we have all the pieces of information that we need. So we're going to write this. We know that's going to be x minus h squared is equal to 4p times y minus k. So we have x this should be -7, excuse me, plus 7 is equal to 4 times -3, -12 times y minus 8. All right, and there is our equation. You can just go ahead, you can leave it in this form. That's just the standard form that we're going to go ahead and be using for our parabolas. The other thing is that maybe just I'm going to check our work a little bit because I kind of want to bring this back to our standard form that we talked about earlier. If we solve for y, so we're going to start by dividing by -12, x plus 7 squared, I lost the squared up here, sorry, there you go, is equal to y minus 8, add 8, so -1/12, I can put an equal sign, times x plus 7 squared plus 8 is equal to y. And now in this vertex form, we can easily see that our vertex is at -7, 8, a dilation of -1/12, and all the things that we need to go from there. All right.